All right, welcome everyone. This is ECS198F, Intro to Applied Cybersecurity. About the course. Yeah, so this class is a strictly pass, no pass only.
Unfortunately, the university will not allow us to give letter grades because we're unqualified or something.
Yeah, totally unqualified. All your grades are going to be a lab assignment only, so no quizzes, no exams. Should be fairly easy. You should put 4 units in Schedule Builder. And this is new and experimental. We designed this course together, so if things go wrong, well, get ready for it.
Prepare for scuff. We're building everything from scratch, so there will be scuff, but we'll try and be flexible and work around things exploding.
Hopefully the fact that it's pass no pass will make it less, you don't have to worry about things too much. We'll adapt to any things that doesn't go properly. But give us feedback. We love to have feedback. This is the first time that we're offering this, and so this is the first time that we're students teaching a course. So we want to know how it feels from a student's perspective.
Yeah, the department wants us to teach this once a year apparently, but we'll see if that actually works out. So if you have feedback and you would like the course to be taught again in the future, your feedback is paramount. Prerequisite to this class, it's listed as essentially ECS 50, which requires 36A and all of that. That's only because the department told us to put that prerequisite on. It's supposed to be an upper division course, but we have no way of enforcing this, nor do we plan to ever enforce this. That's that.
So just make sure, we want to make sure that people have experience with, they know what a computer is. First of all, they've interacted with some programming languages before, and so if that doesn't sound right, then see how you feel after these first couple lectures, and we can talk about it more if you'd like to take the course but you're not sure if you're ready.
Originally, they wanted us to make the prerequisite 150, and we thought that was kind of mean and defeats the whole purpose of wanting to open this up to people.
So realistically, you do need to know how to at least write some code. So taking 36A would be helpful. Most of the things you do in this class don't involve writing code. You might write a couple scripts, but you will need to know how to read code. So that's the main thing. Again, make sure you put 4 units on the Schedule Builder.
Any questions about that?
Okay, so we're the instructors. I'm Ethan. I will probably be in charge of grading all of your assignments, so I'll have a lot of fun doing that.
He's a senior, it's fine. He's taking no classes.
I am taking classes, not no classes. But I'm Ethan.
Hello, I'm Akil. I'm a third-year computer engineering student. I've been doing cybersecurity for a little while now, and I like to focus a lot on network security, firewalls, and infrastructure.
Hi, I'm Jason. I'm the third of these jesters, and I'll be teaching some of the offensive-related stuff, and mostly doing behind the scenes and making sure all of your labs work properly. More on the lab later. Oh yeah, and all 3 of us are from the cybersecurity club. Hopefully that was evident enough.
Ethan's the president, I'm the vice president, Jason is the competition team leader.
So hopefully we know what we're doing.
Hopefully.
Communication. We have a course website. Everything should be on the course website. You will submit your assignments through Canvas. That's where all the grading happens, but if you want to look at lecture notes, the lecture recordings that are hopefully being recorded right now, they should be up on the website. And we have an official Discord, which is the club Discord, and there should be a channel in there that if you fill out the form, we'll add you to that. You can ping us on the Discord channel if you have any problems. That's probably the easiest way to reach us, but you're free to send us an email if you want to.
So we have a Discord, a public Discord server, but we have a specific channel in there that's locked down to just the students here. So make sure to scan that QR code. We'll have this Google form on Canvas as well. Just put in your Discord username and we'll get you added.
Yeah. If you find the need to email us, do you want Davis Cybersec?
You can individually email us, or you can reach Davis Cybersec. That goes to all the club officers, so that'll increase the visibility.
Yeah.
But if you have any pertinent questions regarding the course, you should email us directly.
Email or Discord. We're probably better at reading Discord.
if we go back to the course website over here, our instructor of record is Matt Bishop. So if you're unsatisfied with what we're doing, he's the person to complain to. Yeah.
Actual faculty professor, so he sits above us in the hierarchy. All right.
Well above us.
Well above us.
All right. So next thing is why cybersecurity, Jason?
All right. So actually, I want to get a quick poll from everyone here just to figure out what are the class we're working with. So put your hands up if you've gone to a cybersecurity club meeting.
Okay.
How many of you enrolled in this course through and have not done cybersecurity or just no prior cybersecurity experience? Hey, welcome. Thank you for choosing Davis CyberSec Incorporated. Why cybersecurity? Just what makes this class different from? Actually, who's enrolled in 153A? Yeah. So. So 153A is the official upper div, the real cybersecurity class. What we try to offer with this class is a bit more hands-on. So Professor Bishop teaching 153 will be more of theory. How does cybersecurity work? How does formalize it? We're going to be like, okay, here's a computer. Here's how to hack it. That's kind of the main selling point of this class. I hope you stick on. Cybersecurity is a growing field. It feels tough at first because it is very much, you have to learn 5 trillion different things about how computers and the internet work, and then you can go hack it. But we're going to try and cover it in an efficient way and an understandable way to help everyone along.
Part of the reason why we wanted to offer this course is that a lot of times in our club meetings we get, or especially at the beginning of the year, we get the question, how do I get started in cybersecurity? And it's such a nebulous field that's kind of hard to like even get a foot in. And so we're teaching this course in order to make sure that there's a way that students like us can learn.
Who here is trying to get into cybersecurity? Anyone use any of like the online websites that do like stuff like Hack the Box, Try Hack Me? Stuff. Okay, so kind of, but still they're not reaching everyone. So that's what we're trying to do.
Just a quick check. Can you guys hear in the back? Because there is a microphone here. Okay, perfect. Then we don't need to use it.
Is OBS recording?
Hopefully. There's a little yellow dot at the top right-hand corner of my screen, so I assume that means it's recording.
You should check OBS.
All right, so some more logistics. Supposed to be there. All of the assignments of this course will look like a report. So the first assignment has been released. If you check very early on yesterday, the homework has been changed slightly. So now it's actually doable. So first assignment, we plan to cover Linux, Unix shell fundamentals. So how this course is structured, essentially, we'll cover some basic fundamentals about Linux and Unix shells. That will actually be applied throughout the quarter. You'll likely be interacting with a lot of Linux and Unix systems in the future. So getting these fundamentals down is critical. Now, we do have a no AI policy in this course, but again, we have no way of enforcing this. So if you want to use AI, go ahead.
Let's set it like this. You're free to use it for research and for whatever personal purposes, but anything you submit to us has to be entirely handwritten by yourself.
Yeah.
Does that sound fair?
So again, but I don't have any way of enforcing that.
We'll try, but
Sure. But the other thing is these first couple assignments, you can throw this into AI. We've done that. We know what the output looks like. But in the future, our assignments are going to be done on our own servers. You'll have to VPN into them, which makes using AI a lot harder. You can't throw an agent in there. So if you start using AI this early on in the course and using it as a crutch, you'll have much more difficult time later on. So
Well,
that's
not
the
office
warning.
hours. So if you're really struggling, then come talk to us.
pull up
Yeah.
and
So how does this actually work? Every single assignment, there are 6 assignments in total. First one is on Linux, Unix. Then we have sort of a reverse engineering, binary exploitation, cryptography assignment. We have some defense, offense, and Windows assignments, which total 6 assignments in some way. Oh, there's also a web vulnerability one, that's the third assignment. Every single assignment requires you to write a report. And this is because when you go out into the industry, you will be expected to communicate these ideas via reports. And hopefully this report isn't too difficult. This is what the breakdown looks like. Again, I'm the one grading all of them. So hopefully this is a uniform thing that will be applied throughout the quarter. I will be a little bit more lenient at the beginning, and then it will start to get tightened more and more in the quarter.
We'll provide feedbacks and help you along with what we want to see from reports. But in a nutshell, the philosophy behind reports is, I mean, you know, as the hackers say, proof or GTFO. This is your proof.
So what does that actually look like? So this, again, you need 70%, so a C- in order to pass this course. Shouldn't be that hard. 40% of this report is 3 points. So first, structure. How does the report look like? First page, you should essentially have a brief paragraph, the summary of what you've done. So if this is some sort of penetration testing or some sort of offensive security exercise, I want to know what vulnerabilities you found, how many of them, statistics, maybe how long you spent on this report, the exercise itself. That's the type of things I want to see. If I'm an executive and I glance at this report, what's the main finding that I need to know? Did I have a very vulnerable system? Is this something that actually the company is doing great at? That's what I want to see. First page, 1 paragraph, that's it. Then, inside the report, so from the second page onwards, I want to know the actual technical findings. So if the CEO looks at the report, okay, this company is totally terrible, they're so vulnerable, you're going to hand this report down to the IT team, the security team, and the security team is going to be like, okay, what actually is vulnerable in here? And that's what we want to see in the meat of the report. And that's the technical findings. So methodology. What does methodology mean? It means I need to know step by step how you broke into a system or how you've done something in a report. That includes what commands you run. I should be able to reproduce everything that you've done on my own system that yields the same results. And that's very critical. If I can't reproduce something, that means I can't remediate anything. I can't improve. So that's very critical. I need to see how you've came across that. And in this class particular, I want to know how you came to that solution. Like, why did you choose this pathway forwards into breaking into something or solving this particular problem? And evidence is very critical. If you don't have any evidence, the maximum report score that you're going to get is 60%. That's because no evidence means nothing happened. That's what it means. What is evidence? Evidence is screenshots. So if you ran a command, you should send me a screenshot of the output. This is the command I ran, this is what I see, and this is why something's vulnerable, this is why something is good. That's what I need. So that's the meat of the product, the report. The majority of it should be a lot of screenshots. So if you have like a 10-page report, that's like 2 or 3 screenshots per page, maybe 1 or 2 sentences per screenshot explaining what you've done. Copy in all your commands that you've ran so that I can actually run them as well. And that's how we AI-proof this course as well. Analysis. What does analysis mean? Analysis is a brief write-up about what you've done at the very end. Maybe you've found a lot of vulnerabilities. How would you suggest us to remediate these vulnerabilities? Explain what the underlying theories are, how this connects back to what you've learned in the class. Finally, there's 10%, tone, professionalism, and format. Don't use slang, write proper grammatical English. That's not that difficult. So tone, structure, and the executive summary analysis, those should be 3 points, 40% free already. Meat of it, again, is the technical findings. You want to make sure you know what you're doing, and we can reproduce everything. Questions, yes?
Can you give us a sample report so we have an idea what the hell are we writing? Because it looks like an essay style, but for reports or something like that, because I don't know the format for this.
Yeah, we can try to give everyone a sample about how that looks like, yes. And I'll try to go through this in terms of assignment 1, so you know what to expect and how to format this. Any other questions regarding this rubric over here?
We'll emphasize that part of the process of showing proof and documenting what you did is also allowing us to give partial credit for, even if you weren't successful in some, show us what you did so we can acknowledge your effort for the time you put in. Because, it is really frustrating to just spend hours on a thing and then it yields no tangible result. So we want to, give you at least some credit for the effort you put in.
And the other question is, what is the bottom line for how many loopholes we are supposed to be detecting, because you're just saying like your support, we are giving back our findings, but
Right.
you're not telling us what we're looking for to begin with.
So in each assignment, there is a clear defined goal. There may be many ways of solving it, and sometimes we may actually have vulnerabilities that we didn't even know, for example, put into the machines that weren't intended to be exploited. But if you found one of these vulnerabilities, for example, and you went that way, and we didn't know about that, that's what we want to see in the report.
Okay.
But we will have some sort of clear defined goal, like you want to get into, this particular machine, you should be able to open a file and it has a flag in that. It will state very clearly that's what we want to see.
Cool.
And if you can't get there, come to office hours, we're happy to help. And again, partial credit is awarded. So even if you didn't complete, the objective, and we've seen you made good faith attempts at going about the problem, you'll still get, a pretty good grade, in fact.
Commenting. Oh, actually, you go first.
Is that breakout available on Canvas?
This rubric might be available on Canvas. I'll double check, but it's definitely where is it? It's over here. So it's also on Canvas over here in the rubric, but it's also on the course webpage. Accessible over here, grading on the very home page.
You'll see a common theme with a lot of the assignments, and we'll go over assignment 1, but a common theme is that everything is very open-ended. And so part of the reason why we're doing reports rather than like grade scope checks or something is that it would be impossible to just give you guys a prompt and do like some sort of grade scope check to see if you either got it or you didn't, because the prompts themselves are just too open-ended. And so we're giving you guys reports so that you can explain your thinking, regardless of whether it's a little bit different than what we had in mind. You can still get full credit based on your own interpretations of the problems. Any other questions?
So that's the logistics of this course. If we have no questions, we can talk about the first assignment very quickly. So this is the first assignment, Linux and Unix shell fundamentals. And how this assignment is formatted is we want you to use one single line command per question to produce the information listed below. That means no semicolons, multi-line commands. Can't use something like 2 ampersands, that's 2 commands. But you can use any number of pipes, any number of redirects. So you can pipe things into more and more commands. That's perfectly fine, and you will need to do that. You're free to use command and process substitutions. And by the way, if you don't know what I'm saying, it's totally fine. The first 2 lectures, not counting this one, we will be going over Linux and shell fundamentals. And you are allowed to read and write to any auxiliary files, like you can write to something in /temp. I've given these predefined list of commands that you're allowed to use in this assignment. So use these commands only. If you don't know what they are, we'll hopefully go over them. And I'll also explain how you can do some more research to learn about what these commands do. Part 2 is the meat of the assignment. Part 1 really is some very basic commands. You should be able to look at this, spend 5 minutes after the first couple lessons. You should be able to just write this out easily. Part 2 is where the meat of it is. And this is a lot of the assignments that I create follow this type of structure, which is there are actually multiple ways of solving some of these problems that we've designed it to be solvable. There is a more difficult way, which is part D, without using the awk programming language or the awk command on Unix. As you can see, none of that has awk in there. And it's more difficult than using a command like awk. And that follows throughout the course, where there is definitely a hard way, and perhaps maybe the brute force way of going about it. You might need to spend a little bit more time. But if you sit over here and you think about it, you might be able to find a more elegant and a more, maybe slightly less intuitive, but solution that will make your life more easy. And that's the kind of thing that I want to go about. Part E, you're only allowed to use the command awk, so all these commands over here, don't use them. So you literally put ps awk, pipe it into awk, and you put in that whole program over there. You can use semicolons in that program. And we'll try to have some sort of like little extra credit. But again, this is a pass, no pass class. Hopefully you should all be able to pass this with some effort put in, but shouldn't be too difficult. Any questions? Oh, regarding the report for this first assignment, what does that mean? So again, in the executive summary, tell me very clearly, one paragraph or 2-3 sentences. What did you do? Did you manage to solve everything? How long did this take you? For example, basic statistics. Then, for every single question, I want you to write out, obviously, the command that produced the result. And if you can run them, specifically for part 2, because PSOX is available on all Unix and Linux systems, I want you to actually run the command that you wrote and show me that this actually returned what I asked for you. The top 20 lines of with percentage CPU less than 2% and percentage RAM less than 1%. And if you're using a lot of these pipes, my recommendation is show me at every single pipe stage what the output is and why you're using this next command that gets piped into that, and why that why you chose this next command to sort of more filter down into your final result. So that's what I want the report to look like for assignment 1. Are there any questions?
Does anyone feel a little? Anyone thumbs up, middle, down? Get a vibe check. That's fine. We're going to teach. We're going to teach you everything you need to know for this. It's just we're just briefly outlining expectations for how this is going to look.
All right. In that case, I believe we can get started with some basic fundamentals of what Unix and Linux looks like. Okay. So this is the terminal. You'll be interacting with the terminal a lot in this course, unless you work with Windows. But a lot of this, I'd say 80% of the course, you'll be using the shell. And you'll be using SSH into the various boxes that we have. So getting very comfortable with using this is pretty critical to your success in this course.
Has anyone not heard of SSH before?
Okay.
SSH is just essentially a remote login program. You just type SSH space, and then we'll show the commands in detail. But
It allows you to.
Go ahead.
It allows you to log into a computer remotely through your terminal. So if you have a computer that is on campus and you want to access it from your home, for example, the computers in the CSIF, then you would SSH into those in order to use those computers from the comfort of your own home. So, I believe Zoom is your screen.
Yeah, so this is actually very helpful if you're taking any CS courses. I suggest you, if you have no idea about what a terminal is, this is a great place to, I suggest lectures 1 and 2. I think it's 1 and 2. Yeah, these two, overall introduction of a shell and the command line environment, to get yourself a little bit more familiarized with what this is. But we'll try to give everyone a quick introduction about using the terminal. And yeah, so the first thing that I want to talk about is the man commands. Oh, the terminal is the interface for you to talk to a computer. It used to be the only way you talk to a computer, but now it's not, obviously. You can use the graphical user interface, but the terminal is what a lot of systems have by default, and it uses a lot less resources to run than a full-on graphical user interface. First command that I would like to show is the man command. This will be very helpful for your first assignment. I believe there were exactly 30 commands that you're allowed to use. Some of them you might not be familiar with. The man page gives you documentation, tells you what this command does. How do you read this man page? Well, first line, name. That's what the command is. It tells you it displays online manual documentation pages. That's what the man command does. That's why I put man. Synopsis. It tells you the different options you can use with the command. So you put man, and then you can put these different things called flags, which will help augment your process. And for your assignment, you're allowed to use any flags that you want for assignment 1, for any of those commands. Then we come down to the description. The description tells you in detail what you can do with this essentially program, this mini program. And this one tells you the man utility finds and displays online manual documentation pages. The man pages usually are all actually pre-downloaded onto your computer, so you don't need an internet connection. and it'll tell you exactly what this does. The sections of this manual, there's the general, system calls, all of these other things, and it gives you all these other options or flags that man would be able to display. And if you go all the way down, there's a lot. You can also see some similar commands over here. See also apropos, intro, mandoc, all of these other things that if you're interested in knowing, that will be helpful. And they have some examples. Sometimes the man pages don't have examples. You can always Google. Google is your friend in this class. You'll be using Google a lot. Don't be afraid to Google things. Stack Overflow is very helpful as well. But yeah, we don't know everything. We use Google all the time, so make sure you use that to your heart's content.
What keys are you using to scroll the man pages?
Arrow keys. So arrow keys can scroll the pages, but the normal Vim keys, so G goes to the very top, capital G goes to the very bottom, D and U are the down up by page sections.
I mean, I just use arrow keys and page up, page down. I'm not a Vim power user, so.
Yes, so you might want to learn how to use some sort of a text editor software on the shell. I suggest you use Vim, but I know a lot of people would prefer some other program. There's Nano and everything else. Yes.
We'll talk more about that.
We'll talk more about that later. So the other important thing is some of these commands you will see have this like stat2 that gets bracketed over there. In order to access that man page, you have to put that 2 in front of the command. What I mean by that is if I just do man stat, for example, it shows you the stat1, and sometimes that's not the actual command you want. Man2 stat shows you something different, and that's actually the file status. They're actually grouped by different things. So like I believe the 1 bracket is by default shell built-in commands, 2 is something else, system calls as you can see, and it goes way down the list. Usually each command is only used for one thing, and so you don't actually need that. But if you ever encounter some weird thing like that stat2, that's how you use it.
System calls, that was just straight up C code. That was just straight up how to use the C command. I mean, that's in the man pages, but most of the time for this course, it's just going to be commands. So, I mean, if using it on your own terminal isn't, it's not that intuitive, just hop on Google and just like look up man pages, how to use X command.
All right, so we're trying to go over some of these commands. Very basic ones is how do I actually go into different folders, directories in your computer? Because the shell, you should be able to do everything you want on the shell instead of the graphical user interface. What I mean by that is, for example, this is on macOS, this same on any Unix or Linux-like system. The root folder is the highest possible directory you can ever go to. That shows me everything that gets branched down. So it will look like the root file over here, and it keeps going. So this is the root file, and it keeps going down like usually like /user.
Do you want to use white chalk? That's like, I can barely read it, I'm standing right here.
Let's see, here's white chalk. So you start with the root directory. That's the highest you can ever go. Usually, if you're on macOS, you go to like /home, and then /user, and the username. So like for me, it's like Ethan, and then you keep going down the chain. But there are a lot of other things here as well. Like if you ever, I believe, plug in like a USB drive, it goes to /volumes, and you can access files from there on. The way you actually go to these different files is you use the cd command. And what's the cd command? Well, we just learned that. We can use the man pages. It'll tell you what is the cd command. Forgot about this. So these are what we call shell built-in commands. Shell built-in commands are built into the operating system itself. And they have a very specific man page for all of these commands that are baked into the operating system. So all of those, as you can see, change directory is so fundamental to the operating system that it comes with it no matter what. And then other commands, like I believe like WC, which is a word count command, that is in your /bin directory, so it's actually some binaries that exist on your system. What I mean by that is,
The difference is it's either some of these programs are programs like actual programs that run on your computer, and then when you type a command, your terminal will be like, let me go find that program, run it. Built-ins are built into the terminal program itself. So you might have heard of like bash, ZSH, fish. Just built-in commands are just part of that shell program itself. So it's not like a program you can find, it's part of bash.
yeah, so the way you do that is you find whatever terminal you're using. So right now I'm using ZSH. And so I go to the ZSH built-ins, and I should be able to search with the / key that pops that / down below on the bottom left-hand corner. And I can type in like CD, and it'll bring in everything that's related to CD. So I just search for CD, that's a built-in command. So I can find everything that relates to CD, which is, it says, change the current directory. That's what CD stands for, change directory. It, in its first form, changes the current directory to whatever argument you put in. So if I want to go to, say, this very direct path, /home/user/Ethan/desktop, it will go put me in that directory. Then, if I'm in that directory, I want to know what's in there, I use the command ls. I believe that's also a shell built-in command, so I can use /ls. It searches for everything ls, so let me actually try this. N gives me the next one.
You would click N. So once you type / and then type some keyword you're trying to search for, you can type lowercase n, and then it'll show you the next time that word occurred. It's kind of like doing Control F on a website and then hitting enter, but now it's a shell, so it's slightly different.
Maybe ls isn't a... Oh, ls is not a shell built-in command. You're not expected to list directory contents by default. Well, that's good to know. Sometimes if you ever use CTF challenges, they actually wipe your whole user bin file, so you don't have these very handy commands, and so you actually don't know what's inside a file. There's a file system. There are other ways to output that, but the easiest way is actually use the list directory contents, and it displays everything that's in this current directory by default. And these are the possible, over here, these are the possible flags that you can put in. There's a long list of them. But the one that you might help you the most is /-a. -a includes everything whose name begins with a dot. The dot file name in Linux and Unix means that it's hidden by default, so it doesn't show up in your graphical user interface environment, and it won't show up in the regular ls command. My favorite ls is ls-haltr. H is human readable. Oh shoot, that's a lot of files. H gives you over here. This is the number of bytes, so the file size. By default, it just gives you a long number of bytes. So -h gives it in human readable form, so like in bytes, kilobytes, megabytes, gigabytes. A shows you all the dot files. So as you can see, I have a bunch of dot files. I don't know what this .zshn gives you all your shell environment variables in that file. L gives you this long list term, so it shows me in detail what's going on. So I can see the first one, public, it's a directory, that's why there's a D. Ethan has RWX, which is read, write, and execute permissions. An executable permission in a directory means you can actually go into them. If you have an X that's not a directory, that means you can actually execute the program. R means read, W means you can write to it. Then you have these other things. So I'm also in this group called staff. I don't know why that's the default, but that group has read and execute permissions for that specific directory. The L command, again, this is a long list. T means reverse time. Because as you can see, this is a very long list of files that I have in a particular directory. I use this in the downloads folder. So by the time I finish executing, I'm all the way down over here. T reverses the time order, so I know what's the latest files that I've executed and used at the very bottom, so it's easy for me to look at. R is the one that reverses it. T just lists them in time order. TR gives you in reverse time order. So those are some of the commands the flags that I find most helpful with an ls command.
And you can contrast this with just the default ls, which will output it in like instead of a list, for example, it shows it in like separate columns. So it's a bit harder to read if you're just trying to look very quickly. And it's in alphabetical order rather than time order, for example. So you're using these flags in order to change how the output looks to you, to make it more convenient to you.
Any questions?
Generally with flags for commands, you're using the flags in order to change how it'll keep the same purpose of the command, but you're changing what it does. So for example, for these ls flags, it was changing how it looks to you. For other commands, the flags can do different things.
Give me a temperature check. How are we feeling? Up, middle, down?
Okay. Some other commands that you might.
We'll get you
We can talk more after.
We will. We are still working on getting our infrastructure set up. It should be set up hopefully by the end of this week. This first assignment, as long as you have access to some Unix terminal, like the CSIF, or even your local machine if you have a Mac, or WSL if you have Windows, you should be able to do the assignment. But we will get you all set up with your own sandbox environment for all of these labs.
Does anyone not, as of right now, not have access to any kind of Unix Linux terminal on their computers right now?
Perfect.
Everyone has WSL?
Okay.
Or,
You can
Okay,
start
let
doing
us
this
know
on-
if not, and then we can figure something out.
Cancel down, okay.
But this, yeah, that
macOS.
Mac OS,
Mac,
yes.
Mac OS will work. Yep.
If you have a Mac computer or a Linux computer, then you're all set already. If you use Windows, then if you can get WSL or SSH into the CSIF, that would all be a solution.
You can try stuff out.
All right. Next command that we go over is move and remove. Move is what it says. You just move a file. Move files. That's what it does. Takes a file from one location, you list the file, and you give it a new path, and that moves it to that different location. We can also use this to rename a file, because you will just tell it move from this current location with this name to this new same location but with a different name. That's how you rename a file. rm is the remove command. It removes a file, removes directory entries. So you can remove a file, and that's where the infamous rm-rf slash, it won't let me do it.
We have to do no preserve root.
No preserve root and sudo. By default, this is not sudo. We will talk about sudo later, but rm-rf means remove. The -r flag means, let's look at this. -r is recursive. There you go. Where is it in the man pages?
It was right there.
Was it? Oh, I can't read.
Is there a way to highlight?
There is.
Yeah.
R is equivalent to -r over there. It says removes recursively, which means in each directory you keep going down and down and down. -f means you're forced to remove it even if there's some other extra permission set that prevents you from removing it. And the root file, again, is the top level system over here. So if you use that command, and especially in older systems, it wipes the entire computer. Gone forever. Well, not forever, but mostly forever. There are ways to recover in the security world, but try not to use that command. If you want to delete everything in the lab environment, you're free to do so. But I'd suggest you not to do that.
It's going to be a lot of work for
Any questions?
Any questions? So that's the basic way of navigating around the file system on your computer. Then let's talk about some other fun commands. Echo, for example. Echo should be pretty familiar with you. You type in whatever you want to echo. So this is Ethan. And prints that back up to the screen.
Typically, you don't even use quotes, I think.
You don't. Quotes, let's talk about quotes. Quotes allows you to preserve this whole thing as one string. So if I do this, you can see the spaces are there. If I remove the quotes, it doesn't, because it treats space as one separate argument. So this brings back this is Ethan without those spaces. So quotes preserves the entire structure of the argument. Echo allows you to have a lot of different arguments. So
Any idea why it does keep one of the spaces though? It doesn't like discard the whole spaces to begin with?
So that's why we read the echo command. It says, the echo utility writes any specified operand separated by a single blank space. So every single command, like every single argument, it's separated by one string. That's why it comes back out as one space. All right, so that's probably everyone's most familiar command. But there's actually a different command that does sort of the same thing, which is the printf command. For those who have used the C programming, you might be very familiar with the printf command. I can do this thing. This is Ethan, and it prints it to the screen. With some slight difference over there, as you can see. There's this extra % symbol over there. And that's because printf, by default, doesn't print a new line after your command. Echo does. So if I add this escape n over there, it will bring back the same thing.
This is very similar to how it was in C programming.
Exactly. So if you've written some C program, you might be familiar with this printf command. And you might now be wondering, well, what's the difference between echo and printf? Is it just that one new line thing? And the answer is no. There's actually a big difference between echo and printf. I'll link you to a Stack Overflow page if you're interested. The short answer is, it used to be that printf was the default printing command to the Unix terminal, but people complained that it was too difficult to use because you can use a lot of different things. For example, I can add shell variables into here, well, if I add like a %s, %s, new line, and then I can add, your normal C command like test, then it fills that test into the %s, and it prints that out, so now it's just test. Like you can do all these fancy things with the normal printf command, like you would in a C printf command. Very difficult to use. People complained about it, and we're like, we just want to print something to the screen. Why do you make it so difficult? And so people lobbied for the echo command. Much easier. And then it turned into a nightmare because then everyone was like, echo command is too simple to use. We want more functionality. And so people start adding different functionality to echo. And now echo has many different versions across different operating systems in Linux and Unix. So if you use echo in this very specific way on this machine, it might have a different output, or it might just not work and crash on a different Linux machine. So if you are writing some very sensitive shell script that needs to work across all the machines, you should use printf. But for majority of the purposes, you can just use echo. But I'll link this Stack Overflow page that gives you in more detail about what the differences are between echo and printf. Oh, there is one difference between the shell printf and your C command printf, and that is if you give it more arguments than it ever needs in a printf command. In C, it has undefined behavior. In the shell command printf, you can actually keep using the same arguments and writing a lot. I believe it's somewhere in the man pages, but that's besides the point.
For most of the assignments in this class, you'll be fine using echo. Printf is more of a if you really want to in later on.
Yeah, if you want to format some, very specific, using calculator and, I only want 3-digit spaces, then you want to use printf. Otherwise, you can use echo, and usually echo is more than enough. All right, some other commands that are useful to know is the cat command. The cat command shows you contents of a file. Technically, what the hell just happened? Okay. What the cat command actually does is it takes multiple files and concatenates them and then prints them out to the screen, which is why people just use it to concatenate a file, to print out a file. So for example, if I have hello.
Bro, HDMI troll, are you kidding me?
I do remember this building being very
Okay.
Is it back? Okay.
Okay, so for example, if I make a text file, this is Ethan over here, and I save it, I could use cat, and it prints that back out. And if I have multiple files, hi, this is also Ethan. Then I can do cat, hello, and hi, and now it prints both files, concatenated with each other. That's why it's called cat. There's also a reverse command called tac that reverses the file. Oh, I actually don't have it on by default, but there is such a command on some Linux systems. Next one is pwd. Pwd just tells you, asks you, where are you on your system? I'm at /users/Ethan. That's where my directory is. And that's what we call the default user directory, and that's why I'm at that tilde. So the tilde expands out to that full user/Ethan.
So PWD stands for print working directory. It shows you where you currently are. You can see this tilde over here in Ethan's terminal. That's representing his user folder. It's just like a shorthand way of writing that. But if you type pwd, it'll show you the full path, which is /user/Ethan.
And if you go into like a subfolder of /user/Ethan, it'll just abbreviate it tilde/ and then that folder.
Give the other notes.
No. All right. Any questions so far?
Just to pull it up.
Okay, can you go on?
Yeah.
All right, some other, so these are the most common commands that you'll ever encounter. They're very helpful in moving around the directory, moving around your file system. I do realize that I forgot to include this very useful cd dot dot. Cd dot dot just means I want to move up one level of my directory. So if I'm in like /home/user/Ethan over here, if I'm to move back to /user, I can just do cd dot dot. And in this case, you can see I was at /user/Ethan. Now I'm in /users.
CP.
All right. Some other commands are copy. Did I not go over copy? Oh, I didn't. Copy just copies a file. It's like the mv command. Instead of moving a file, you copy it from one place to another. Again, the man pages is very helpful. Sometimes you might mix up which is the source file, which is the target file. So use the man pages. It will tell you exactly how to structure the command.
We do less height and tail.
Okay. Any questions so far?
Are we boring you? Yes. If it. Yes.
Who's being bored right now? Okay.
That's an okay answer.
Start doing the assignment then.
Because that is a good sign. It means that some people will, already know some of this material. If not, that's also a good sign because it means we have something to teach this first lecture. But yeah.
All right. Some of the other commands that you might see are head and tail. Head gives you the topmost n lines of a file, so man head. It displays the first n number of lines of files. By default, I think it's like 5 or 10. 10. By default, it's 10, but you can use the -n count to limit the number of lines you want to see. Tail does the opposite. It brings you the bottom x number of lines of files. The less command and the more command pages certain things. So in your assignment, you have this psaux command. If I pipe this into less, now I can actually use the page instead of it just showing me the entire terminal output, and then I have to go use the mouse to scroll. I can go and page this and go up, sort of like the man pages. So the man pages actually uses the less program to do this pagination.
So you can compare it to just how psaux runs by default. So if you just type psaux, you hit enter.
And it just gives you everything. And then unless I use and I enable scrolling on my terminal, I can't actually go back up.
And mind you, all the terminals don't even have scrolling as a feature. So you can just use your trackpad right now in the modern day to scroll around. But if you're using an older system or a system with fewer features that are still used today, you won't be able to scroll. So the point of less is so that you can go and read your whatever command output in a way that's supported on all systems to scroll between.
Yeah, and I realized I never mentioned how you actually exit out of these pagination systems. So if I went back to one of the man pages, how to actually get out of here, you use the Q button. Q quits. I believe Control-C might actually also work. Let's see. Oh, it doesn't work. Use Q. Okay.
Control-C doesn't work.
Control-C doesn't work.
It's over.
So some of the other fun things, as I was alluding to, Control-C kills the program. So if you have some long program, maybe you have 1,000 what'd you say? So it depends on what your terminal is. So how do you copy on the terminal? If you're on a Mac, you're lucky because Apple has kept Command and Control separate, so you can use the Command C button for your normal copying and pasting activities, and the Control button for actual terminal input. So for those of you who have Mac and are wondering why there's a Control button on your keyboard, that's really the only reason why it still exists. It's thanks to us computer science folks. If you're on Windows, I'm sorry. You have this lovely Windows button, maybe a new Copilot button. Pretty useless in my opinion. So there's no way for you to actually do nice copy and pasting with your control key, because by default, if you're on the shell and you use the control key, it means the actual normal control button. You might have some weird way of doing, Control-Shift-C or Control-Shift-V, but that's system dependent.
Control-Shift-C works most of the time. Yeah, it'll work. Control-Shift-C works. You're just mad you had to invent a new button.
We didn't invent a new button, okay? This button has been here for a long time. Yeah, so if you have some long-running, command, maybe this PS command, you actually have like 10,000 processes running in your computer, and it's taking forever to output, you can use Control-C, and it kills the program and returns you back a shell. Some other commands that are fun include date, watch, kill. The kill command kills the process on your computer. So as I've shown you, the PS command lists all your processes. That's what this does. So if I see some random process that's executing on your terminal, maybe you've been hacked and you're like, why is this going on over here? Why is this running? I can use that to kill one of these processes. So if I want to kill Discord, I can do like kill-9, I think. And you have whatever user ID there is. You can use that, or you can use the kill all command, which if I do kill all like Firefox, and it reps all of Firefox processes, so it finds all of those and it kills them. I'm not going to do that. That's why I use Control-C, it just exited out of that without executing. That's why you see this xint on there.
If you've taken 150, then you might know more about this, but you can see that second column there is PID, is the ID of the process that you're running. And you don't need to worry about what that means, but it's how all you need to know is that that's how the operating system will refer to the process. So if you wanted to kill a process, then you would use the PID to refer to it. Every process has its own ID. So that's how you make sure that you're not killing the wrong. Like for example, if you have multiple Firefox windows open and you wanted to use the terminal to kill just one of them, that's how you make sure that you're closing the right one.
All right. Another command that you might find helpful is the strings command. Strings command takes binary file and then outputs anything that remotely looks like an ASCII string. So you might be able to look for hidden secrets in an executable file, or you might have this long binary and you want to see what's going on in there and trying to find anything that looks remotely like a word.
Yeah, for example, like a quick example off the top of my head, you compile C code into an executable, and normally you can't read it, but you know that maybe I have a hello world string inside of it. It just runs strings, it will sort through all the binary data, grab that hello world string, and you can see like, oh, there is a string inside of my binary program. This will be a surprise tool that will help us later.
A lot of these will be helpful later. Another command is touch. The touch command touches a file. It changes file access and modification time. So by default, as you may have seen in one of my outputs, if I do ls-hal alter, it gives you when the last modification time is. And if I decide to say touch json.pub,
what do you mean by that?
that's your public SSH key. But if I touch json.pub, it should update the file time to the latest. As you can see, March 31st, 1435, that was just now. I just touched json.pub, updated the file access time. No malicious meaning over there.
It's also a way to kind of create a file. That's how a lot of us think of it, as just a way to. So for example, if you wanted to make a file called hello world, you would type touch hello world.
So this is the line over there. If that file doesn't exist, it is created with default permissions. So I can now touch an akil.pub. There we go, I touched everyone. Now,
what do you mean by that statement?
Now both JSON and akil.pub exist on my system.
And you can see it's an empty file, so go back to
Oh yeah, so if I If I cat json.pub, that's Jason's public key.
Please put that on your computer so I can learn. I need this.
But if I do cat kill.pub, it's empty. There's nothing in there.
And you can also see in the listing here, JSON.pub is 96 bytes. If you count that, that would be 96 characters, I assume. And then if you see mine, it just says 0 bytes.
All right, perfect. I'm glad we had breaking format. Other commands that are listed that you can use in your assignment are fun things like date. Date, well, gives you the current date and time, actually. But there's a time command, and it actually doesn't give you the current time. What it does, it allows you to time how long a program executes. So the time command is usually used in terms of putting in another command in there, and you're trying to see how long does this program execute. So if I have some very long program that I'm trying to figure out if this is more efficient than some other version that I created, you can use the time command to quickly figure out how long it took to execute. Date command actually gives you the date and the time of where you are currently. Usually the system time by default.
Does that make sense? It's a bit of a confusing. So date returns the date.
And time.
Date and time. Time will just time a command. So it tells you how long it takes to execute. So for example, if you want to see how long it takes to cat a kill.pub, you could just time. Or
So there.
if you want to see how long it takes to run date, you could run time date, and it'll show that it took
0 seconds. It was very quick on my computer. It used 0.009% or 0.09 of a CPU to run this command.
I sure wonder how long it takes to run sleep 5.
Yeah, we can try that too. Times sleep 5. Sleep is a command that just sleeps for 5 seconds. And sleep 5, why does it say 0.00 seconds?
from the user's perspective.
From the user's perspective, yeah. It took me 0 seconds to run this because the sleep command basically times out and it comes back into effect 5 seconds later. So the time command isn't the most accurate way of doing things. That's why when we actually time programs, we write it in like Python or whatever, and it says this is the start time using something like a date command. This is the end time. We subtract that and it actually gives it. So the time command is sometimes useful, sometimes not.
But you can see at the very end, it does say 5 seconds total,
Yeah.
approximately. So yeah.
The BC command stands for the basic calculator. It's an arbitrary precision decimal arithmetic language and calculator. It's sometimes helpful, sometimes not, in my opinion. For example, if I do very basic calculation, 10 divided by 3, it's, shoot, I have to echo. This is where echo comes into handy. 10 divided by 3, pipe this into BC. It tells me it's 3. Because it doesn't, by default, do calculations the normal way. You have to do the -l command to actually make it print, with decimal precision. Why do I have to use the pipe? Why can't I just use BC? Well, if you look at the BC command, it, by default, doesn't actually contain any string input over here compared to some other program like ls. Like over, let me see if I can find. Come on.
Just enter.
If I man something like strings, for example, no, what's a command that requires, man echo. Why didn't I just do that? So if I look at echo, you can see I can pipe in some random string, and that will just take that string in, and then repeat that. The BC command doesn't take in some random arbitrary string, and only takes in files, or takes in some standard input by default. So therefore, I can't just put in a string because it will just interpret that as a file name. And therefore, I had to pipe it in. Piping basically takes whatever output that was and turns it into some standard input. So that's the BC command. Find command is a command that finds some files in your operating system. It walks through the file hierarchy and it just keeps trying to find a certain file, usually within the name.
does it go for lower in the tree, or does it just go over the whole system?
It starts.
So it goes from whichever path you give it to start with. So as you can see, so some of those brackets means it's an optional flag. As you can see, the path is never optional up there.
These ones are optional.
Those ones are optional. That path is never optional. As you can see, you can either put this path in or you can put that -f path in. So you must specify where it needs to start walking, and it goes down. So if you go from /, it will walk through your entire system file to find something. But if you start from this /user, then it just comes from user and recursively goes down.
Is there a difference between doing like CD backslash or CD without anything?
CD /?
No, it's the
What
same.
do you
Well,
mean?
CD without any arguments. We can try it actually.
So CD without any arguments goes to your default tilde.
So right now we're at user bin. If you type CD, now it takes him to his home directory.
The home directory, you can actually echo home. So that's by default home directory. So when you do CD without any arguments, it goes to the home variable location.
So it's not the same as the backslash, right?
No, so if you just type in, well, it's a / on Linux systems, but if you just type in CD /, that'll take you to the
Very top over here.
Oh.
that make sense?
One thing that I've realized about this is a tangent. I can actually go to users and I can put in any number of slashes. As you can see, it goes to that directory. So you can put in any number of slashes you want. You can also play with something like cd /users / /users again /ethan // and you can keep playing around with this, and you can add any number of slashes, and it'll bring you back to I think this is root. That is root. So this sometimes makes for fun obfuscation techniques. If you're just trying to see, prevent a user from accessing a certain directory with some sort of regular expression, you're going to have a hard time playing with that when you are allowed to do such weird things on the Unix shell. Any questions? All of these lectures will just be us going over different things, and then we might have new tangents and new stories to tell about these things. And I just remember there's one very critical thing that I have to mention about this class. This class teaches you practical cybersecurity knowledge, which means you will learn how to hack systems, you'll learn how to defend systems. It's very important. You're only allowed to do things on either systems you own or systems that we own and we have given you permission to touch. Otherwise, you will get into a lot of trouble. Unauthorized access of systems is against the law. You can be prosecuted for that, and I suggest you try not to go out of scope. So every single thing that we tell you to do on our system, for example, we say you're allowed to go hack into this particular system, we'll give you this thing called a scope. A scope is this range of either IP addresses or machines that you're allowed to target against. If you go out of scope, that's not allowed. It's not allowed in terms of the law. It's not allowed in terms of the class. We have procedures in place to prevent you from going out of scope. But if you ever go out into the real world, and if you go and actually run a penetration testing, for example, and you go out of scope, it is huge trouble for you and your corporation. If you're working for a corporation, it's huge trouble for the client as well. So
we're not gonna jail you for like misinputting an IP address and we're trying to put safety rails in place so that the stuff you'll be using to attack our networks won't be able to hit like, I don't know, target.com. But just just work with caution. I will say that like the attacks we're gonna be using in this class they're not like high level enough to be like instantly, oh my god, I just blew up, I don't know, a military base or something. Normally they'll get blocked by firewalls and like people who have professional experience in cybersecurity, but again, don't try and go outside the walls because bad things might happen.
So the class is designed that you have to VPN it into our system, so you'll be within our network when you perform any of these tasks. If you run them, you know, an Nmap scan, for example, on your own network, that's allowed technically. But
If you don't know what that is, that's okay.
Yeah.
But like if you're allowed to like scan your own networks, that's totally fine.
so anything you own, you can, you know, feel free to attack whatever you want to attack if it's on your own machines. But when you're VPN into our system, you're fairly constrained and confined as to what you can do. Don't try to break our environment. We have tools to detect that. We will send you to SJ if you keep trying to do that. So please don't.
we trust it won't happen, but
It's very important.
Or we're trying to set up environments
They
for.
deserve the egg, yes.
What you say?
that did come to
Not
mind.
that good, they deserve the egg.
Well, that is if you don't.
If you actually break it, if you actually manage to escape that, we'll be very pleasantly surprised. We have some techniques in place to prevent that.
But
Don't
if
go
you
tr-
do, but if you do find something, let us know. There may be extra credit. We'll figure it out from there.
Imagine shutting down the whole CSIF work university, yeah.
It's our network is isolated from the university, so shouldn't touch the university either.
If you're able to do that, that's even scarier.
Yeah.
So.
I don't even know how to run my business.
All right. Any questions so far in terms of the assignment, the reports, and these basic commands? All right. I will want to preface this with there are again 30 commands that are listed for the assignment. I won't actually go over every single one of them. You should try to learn things on your own. Part of the course is designed is that you will try and learn different things, Google things, and use the man pages, use these other online resources. We might have links that are attached to the lecture notes that you can view. But we're here to help you learn. We're not here to teach you everything that you can possibly know under the sun. We don't know everything under the sun either, so
Heck,
it's
I don't
impossible
even
for us
know-
to do that.
I mean, I'm not sure if I could like list off what all of these commands do, but I'm confident in my ability to read the documentation and figure it out, and that's what we're trying to impart upon you: the ability to just understand what something does and use it effectively.
Any questions? Or any questions on the commands that we've covered today? Again, we have a Discord server, which is where we'll do class communication, and if you have any questions, feel free to put them there, and the three of us can respond. We're also reachable by email, of course, but Discord is preferred.
Yep, that's pretty much what we wanted to cover today. If you have any questions, feel free to talk to us.
Do you want to demonstrate like why these commands aren't like the specific not allowed stuff for the assignment?
What do you mean not allowed stuff?
Just like what semicolon and multi-line commands.
Okay. So what semi-line and multi-line commands? That's something like you basically execute two commands in process. So ls-halter, for example, that's one command. I usually hit enter, but I can also do something like do this. Actually, let me do it in the reverse order. So I can do cd first, so it changes myself back to a certain directory. Then I do an ls over there. So that executes the cd command first, then it executes the ls command.
It's like typing in two separate commands, like doing cd, enter, ls, enter. It does that in one line. We don't want you to do that for this assignment. We want it to just be one long command of like piped commands, and we'll talk more about that on Thursday lecture.
If you have questions, ask us. Is this good? Or
Yeah, this assignment is not due this Sunday. It'll be due the following Sunday night at 11:59 p.m. So there's time, and we'll talk more about some of the relevant commands between now and then. So yeah, go ahead.
So for this one, we don't have to ask the same anything, right?
You don't have to, no.
We just, we have like, because I know we set to assume a program, so we're just,
Yeah.
Yes,
Even on the actual system, that program won't be there. It's a hypothetical.
It's a hypothetical scenario. So for example, you will have something that's asked you to think about that. There is no screenshot that you'll have to take. You just have to give us a command, explain why this is the case. For A, B, and C, it should be fairly intuitive after the first couple lessons. But for Part D and Part E, I do want to see screenshots of your particular output and why it works.
Yeah, good question. We are trying to get our infrastructure up. We don't have an internet connection quite yet, and that's something we're working on with. You don't need to worry about that, but
there
yeah.
is a server in Kemper that we own that you will be using to do all the quote most of the assignments.
So once that's set up, we'll put an
You also
out.
give access to that.
Yeah,
Yes.
we'll do that.
We'll get access to it.
For the time being, you should be fine with your own. But yeah.
All right, that's it. I hope this is recorded. If it is not, well, my apologies.
For like the assignment one, are we supposed to do like a command for like every subpoint or every part?
Every subpoint. So A should have one command, B should have one command, C should have one command, D should have one command, E should have one command, F should have one command.
And do we like create our own ECS198F program?
No, if you really want to, you're free to do that. You do get if you have some creative solution that we haven't thought of. It says so in the rubric. You can get up to 10% extra credit for the assignment.
Part, E, the one with aught, can we like do aught and then type that in something else, or?
No,
Just all.
just awk.
Okay.
Yes.
Good question.
But yes, if you want to have some creative solutions to some of these problems, this assignment you shouldn't have creative solutions, but maybe you do. It's fairly restrictive after all. But if you have some creative solution, even if it doesn't work, you can get extra credit. All right, that's it for us. Thank you for stopping by. We hope you enjoy the class.
Thank you. We'll be here if you have any questions.